The protocol law enforcement use when investigating a murder is before looking for any of evidence what kind of search pattern we have to use. Documenting the scene with photograph of all access points, shots from four corners of the room, and close-up pictures of the evidence to ensure the proper identification, handling, collection, and packaging of physical evidence found at a scene, and to perform examinations that would aid in reconstructing the events of the crime. Once all evidence is collected, they bring it back to the lab for processing.
When processing blood at a crime scene, we rely on differences in antigens on the surfaces of red blood cells in samples. We take a blood sample and add A antibodies, B antibodies, and anti-RH to 3 separate wells. When we begin to see clotting in wells, we can pinpoint a blood type. Although blood is not individual evidence, it can help us narrow down suspects. After testing the blood found at the crime scene, we discovered 3 types of blood: type A positive, B negative, and O negative. As far as physical properties of blood, blood is very viscous, has a high tension, and falls in an oscillating sphere. Many things can change the way blood appears at the scene. Height changes diameter up to 7 feet, and there are passive, spatter, and altered blood stains. The blood found on the lockers and ceilings was O negative, which would point to Sarah being O negative. The blood spatter was cast off, and it was O negative. Cast off on the ceiling could be evidence that Sarah was hit more than once on the head. The blood found north of the leg was A positive and matches Charles' blood type. This could be evidence that there was an altercation between Charles and Sarah in the time that she was murdered.
Gel electrophoresis is used by scientists to sort DNA strands according to length. Using a micropipette, DNA samples are placed into holes at the end of the gel. Gel is the filter which sorts the DNA strands. An electric current is added and DNA is pushed through the gel. The shorter strands are able to move faster and get to the other side quicker. DNA of the same lengths moves at the same speed and are grouped together. The DNA is then stained to be able to see where the groupings are. The result are gel bands. The gel bands from the DNA found at the crime scene are compared to the gel bands from the DNA of the suspects to see if there is a connection. There was 6 unknown DNA found at the scene. We took samples of DNA from suspects Lori Polk, Charles Brown, Claire Cunningham, Missy Ketrovich, and James Herman. We compared the unknown DNA at the scene with that of the suspects and were able to make connections of the DNA. We found Charles Brown's DNA in the blood found just north of Sarah's leg and also in the bloody handprint on the locker, which is 3 and 7. Claire Cunningham's DNA was also found at the scene in passive blood drops north of the victim's head, which is 5. The rest of the DNA was confirmed to be the victim, Sarah's. None of the other suspects' DNA was found at the scene.
To analyze hair from the suspects, we will use tweezers to pull directly from the scalp in order to get a follicle containing DNA, and we look at the hair under a microscope to determine the medulla and cortex. Once we have analyzed hair from the suspects, we can then compare them to any hair found at the crime scene.
The crime scene labeled A, B, and C. When we place the hair under the microscope and try to match up the hair, we know that hair sample A had an intermittent and an imbricate cuticle that matched up to Sarah Smith's hair. In another sample, B, we found it matched up to Claire. She had an absent medulla and an imbricate cuticle. Lastly, we looked at Charles Brown, who was student witness 1. His hair had an absent medulla and an imbricate cuticle.
We leave behind fingerprints almost every time we touch something. As friction ridges develop, perspiration glands are formed and connect to pores in the epidermis. Pores release waste materials such as sweat, oils, proteins, fats, and other materials. And when fingers touch surfaces, these wastes are deposited, forming fingerprints. Fingerprints are individual and are a great tool for identification. Fingerprints are individual evidence and cannot be erased. There are many common ways used to lift fingerprints. Some fingerprints are visible and you can see marks left on a surface by dirty or oily fingers. Dusting is usually used for this type. Other prints are latent and you cannot see them, but there are always marks left behind sweat, amino acids, and other organic residues from the fingers. Fuming is often used for this.
The fingerprints we found on the bat handle seem to have a double loop. When we looked at all the possible suspects, it seems that Charles Brown's left thumb seemed to match the double loop pattern on the bat that was used to attack Sarah Smith. We noticed that he had a bifurcation and enclosure, which matched the one on the bat handle. When we looked at Lori Polk's left index finger, it matched to the arch pattern that was on the bench. Most coaches sit on the bench in the locker room to talk to players before the game. We do not believe Lori had any play in the crime. We also noticed that Charles Brown had the same bifurcation and enclosure for the bloody handprints. Lastly, we looked at Claire. When more information came out about her and her hair, we noticed that she had a whirl and a bifurcation and a dot that matched exactly like the one on the locker room that was used.
I can't believe that you touched me in the face.
And I'll do it again too.
Stop! What are you doing?
Get off me!
Oh, my leg! I'm bleeding!
Sarah, stop.
Ah,
What was that? Screaming!